Swinburne University of Technology.
Hi everyone, welcome to the Week 3 lecture. This week we'll start with a brief review of what we did last week. We'll have a look at how to write a formal report on the distribution of a single variable. We'll talk about the difference between a research question and a hypothesis, and we'll introduce two significance tests or hypothesis tests, the one-sample t-test and the binomial test. Last week we looked at using different analyses to describe a distribution depending on the way the variable was measured. So for categorical variables we'd use the frequencies procedure, and we would look at the frequency table and a percentage bar chart to describe the distribution. But for metric variables we'd use the explore procedure, and we would use the table of descriptive statistics, percentiles, a box plot and a histogram. We also looked last week at the normal distribution, and in particular at the very special property of the normal distribution, that 95% of values in a normal distribution fall within 2 standard deviations of the mean. So we can say that any value that's more than 2 standard deviations away from the mean is an unusual value. This week we'll take things a little bit further. We'll look at how to take the output produced by the SPSS procedure and to use it to write a formal report on the distribution of the variable. So let's suppose that you were interested in buying a house and you wanted to know what the house prices looked like in your area. We have a record of the price in thousands of dollars for a sample of 542 houses. So how would we go about analysing this data? We'd start by asking ourselves how the variable was measured. So price in thousands of dollars is something that naturally occurs as numbers. So this is a metric variable. We'd use the explore procedure and produce some summary statistics, percentiles, a box plot and a histogram. So here's the output that we produced for the distribution of house prices. So first let's have a look at the way the variable is distributed in our sample. You can see that the house prices are positively skewed and that we have a couple of houses that are unusually expensive. The median house price was $430,000 and the middle 50% of houses were priced between $390,000 and $550,000. So what would we include if we were going to write a report on this information? When you're writing a report describing the distribution of a metric variable, you should talk about the shape of the distribution, the centre, that's what's typical, the spread, and any outliers. To help people visualize the shape of the distribution, you'd include a histogram. And then you'd describe the shape. For example, you might say it was symmetric or positively skewed or whatever happened to be appropriate. For measures of central tendency, for what's typical in the data, if the distribution's symmetric, then you'd report the mean. But if the distribution is skewed, or if it's got outliers, then you would report the median. When you're talking about the spread of the distribution, it's a really good idea to give the middle 50%, so we talk about the first quartile and the third quartile. If the distribution's symmetric, you'd also include the standard deviation in your report. With outliers, you should be not only saying that there were outliers, you need to be saying whether they were extremely high or extremely low values, and you should be giving the actual figures. So let's have a look at the report that we might write for the distribution of house prices. So we start by presenting the histogram, and we refer to that in our report. The distribution of house prices in a sample of 542 houses is displayed in Figure 1. And over here we have Figure 1, that's the caption, and we've given it a title, Distribution of House Prices. You'll notice that we didn't say, in the histogram below. We said in Figure 1, we actually referred to the caption. So then we go on and we describe the shape of the distribution. So the distribution is positively skewed, and we report the median. So we don't just say the median was $430,000, we interpret the median. 50% of houses were priced at $430,000 or less. We then report the first and third quartiles, but again we don't say the first quartile was and the third quartile was. We say something like, typically houses were priced between $390,000 and $550,000, with half of the houses priced within this range. And then at the end we will report the outliers, so 2 houses had exceptionally high prices of over $1 million. So now let's look at a different example. Suppose we're interested in the time that university students spend watching TV. In particular, we want to know whether university students spend more time watching TV than Australians in general. Now, we've picked up some information on the internet that tells us that on average Australians watch 3.2 hours of television per day. How would we go about addressing our research question? The population here is all Australian university students, but we can't go and ask every Australian university student how much time they spend watching TV, so we'll have to work with a sample. We take a sample of Australian university students, we ask each person in the sample how much time they spend watching TV each day, and we record it in hours. So this is a metric variable. We'd start with the explore procedure to see how time spent watching TV was distributed in our sample. So suppose our results look like this. We can see from the histogram that the distribution of time spent watching TV is approximately symmetric, and in the descriptives table we can see that in our sample the mean time spent watching TV was about 4 hours, with a standard deviation of 1.5 hours. So the mean in our sample of students is certainly greater than 3.2 hours, the mean for the general population. But this is just one sample of Australian university students. It's not everyone. So we wouldn't expect the mean of the sample to be exactly the same as the mean of the population. If we had to guess, our best guess for the mean of the population would be 4.037. But is that likely to be exactly the same as the population mean? And have we got enough information here to convince us that the mean of the population, all university students, is more than 3.2 hours per day? Now there are two approaches we could take here. One is to look at something called the 95% confidence interval for the mean, and the other is to do something called a significance test. So we'll look at each of those in turn. We'll start by looking at the 95% confidence interval. In the descriptives output, you'll see something called the 95% confidence interval for the mean, with a lower and an upper bound of about 3.9 and 4.2. So what that tells us is that we can be 95% confident that the mean time spent watching TV for all Australian university students is somewhere between 3.9 hours and 4.2 hours. So it certainly looks like students watch more TV than the general population, where the mean is 3.2 hours per day. We could approach our research question more directly by doing something called a significance test, and the appropriate test here is the one-sample t-test. So let's have a look at the output from the one-sample t-test. The first table here contains much the same information as the explore procedure, so it tells us that the mean in our sample was 4.037, and it tells us that the standard deviation was 1.51. The second table contains the actual significance test. So let's start by having a look at the mean difference. The mean in the sample, 4.037, was 0.837 hours higher than the reference mean, 3.2. So that's the mean for Australians in general. Is this a convincing difference? Well, with all significance testing, we have a very simple rule. If the significance figure, or more commonly it's referred to as the p-value, is less than 0.05, we say that the sample mean is significantly higher than the reference mean of 3.2. In this example, the p-value is 0.000. That's definitely less than 0.050, so our sample mean is significantly higher than 3.2. That is, we've got enough evidence to convince us that on average students spend more time watching TV than Australians in general. When we report a t-test, there are 3 statistics that we must give to support our significance decision. We have to give the value of the t-statistic, the number of degrees of freedom, df, and the significance figure, or p-value. And we report them like this. So we say t, and then the degrees of freedom goes in here in brackets after the t. We give the actual value of t, 11.67, and then we report that p is less than 0.001. So note that when SPSS gives you a p-value of 0.000, it's always reported as p is less than 0.001. We need to be really careful with the language here. Significance is another of those words that has a different meaning in statistics to what it has in everyday English. So in stats, significant doesn't mean that the difference is important or that it's large or substantial. It just means that the difference is big enough to convince us that there's a difference in the population. Now, in this one sample t-test output, there's another set of information that's really useful, and that's this 95% confidence interval for the difference. The first confidence interval we looked at was the 95% confidence interval for the mean, and that told us we were 95% confident that in the population of all Australian university students, the average time spent watching TV was somewhere between 3.9 hours and 4.2 hours. Now, that's consistent with this 95% confidence interval for the difference. Here, we're 95% confident that the mean time spent watching TV for Australian university students is somewhere between 0.7 hours more and approximately 1 hour more than for the Australian population in general. If you look at those figures carefully, 0.7 hours more than 3.2 hours would be the 3.9 hours, and 1 hour more than 3.2 hours would be the 4.2 hours that we got in our first confidence interval. So these are just two different ways of expressing the same information. So let's have a look at how we go about writing a report on the one sample t-test. When you write a report for a hypothesis test, you should always start with the research question or the hypothesis that you're trying to test. And then you give a bit of information about the sample, what kinds of people and how many people were included in the sample. You say what sort of test was used. You state if the test was significant or not, and you give supporting statistics for that. You interpret the 95% confidence interval for the mean difference, and you finish with a conclusion that relates back to the original research question or hypothesis. So for the example we've just been looking at, this is what the report would look like. We start with our introductory sentence. A study was conducted to investigate whether university students spend more time watching television than Australians in general. So there's our research question. We then talk about the sorts of people that are in our sample. So in a random sample of 444 Australian university students. So we've given the sample size and what sorts of people we've included in the sample. Then we give some information about the mean and standard deviation in the sample. The average time spent watching television was 4.04 hours per day, with a standard deviation of 1.51 hours. And we compare that to the reference figure that we've got. This is more than the average 3.2 hours per day recorded for Australians in general. So next we'll mention what kind of a test we used, a one-sample t-test, and we report the result of that significance test, that this difference in mean time spent watching television is significant, and it's really important that we state explicitly that the difference was statistically significant. And we back that up with the appropriate statistics, the t-value, degrees of freedom, and p-value. We then report the 95% confidence interval. The 95% confidence interval indicates that university students watch between 0.70 and 0.98 more hours of television per day than Australians in general. And then finally, we finish with a conclusion that relates back to our original hypothesis. As suggested, university students spend more time watching television than Australians in general. So in summary, there are two ways that we can generalise from our sample to the population. We can use 95% confidence intervals, or we can use significance tests. If we want to compare a sample mean against some known reference mean, then the appropriate hypothesis test to use is the one-sample t-test. So a one-sample t-test is always used for metric data, where you're comparing a sample mean to some known reference mean. So what we've been looking at here is statistical inference. We're using the sample to infer something about the population.
This has been a Swinburne production.